Hello class, today we'll look at graphs of logarithmic functions. We now know what a logarithm looks like. We know where it's coming from. It's when you try to um, do the inverse of an exponential function, you end up with a logarithmic expression. So let's look at what the graphs of a log function looks like. So recall that we said that if I have this exponential function here, clearly a is greater than 1, so this is f of x is equal to a to the x. This is at 0, comma 1, and I also have a horizontal asymptote at right here. In the previous video, we realized that this passes the horizontal line test, meaning that the function a to the x is 1 to 1 and will have an inverse. Well, to find the inverse, there's so many ways we could do this. One way was we could get some point on this curve and then interchange the x and the y and plot those. Or we can remember that if a function is 1 to 1 and has an inverse, then that inverse function is the function where ax is reflecting about the line y equal to x. So let's assume we have this line y equal to x right here. Then we are saying that this reflects right about here. So this is what we're going to call 1, comma 0. And then the nature of the curve is going to reflect in this manner. Well, that's how the reflection is about the line y equal to x. What's also going to happen with the horizontal asymptote? Well, it seems like when you reflect the horizontal asymptote along the line y equal to x, it switches to the vertical asymptote along the y-axis. So we have x equal to 0. And then this is what we are calling log ax, which is the inverse. Or you can call it as a new function, g of x. Okay, so quick proof on that was, recall that we said y was equal to a to the x. If you interchange them, you get a to the y. And now that we have this logarithmic tool, we can pick it up and go, well, to resolve this y, which is a power, I got to find a way to bring it down or to make it available to me. The way it looks like, I can't really do much. But if you convert it from an exponential to a logarithmic function, we end up with log. The base is a. We know that every log returns back to us an exponent. So I know that the output is going to be y, and then the argument is right there. So this is what we are calling the f inverse, which in my case I called it what? G of x. All right, well, let's look at some characteristics of this function here. So if you have g of x equal to log a of x, we know the domain. What is the domain? The domain is all the x values that this function can take, and it looks like it's going to be 0 to infinity. How about the range? The range seems like it's y belongs to what? All reals, so from negative infinity to positive infinity. And then it's also got a vertical asymptote, which is at what? X equal to 0. So this is no brainer for us, because if you look at the characteristics of f of x equal to a of x, its domain was what? X belonging to what? All reals. Its range was y belonging to 0 to infinity. And then it had a horizontal asymptote at y equal to 0. And we said if things are inverses of each other, then the domain of f of x would be the range of the inverse, and then the range of a of x would be the domain of the inverse function, logarithmic function, and obviously the horizontal and vertical is just switched accordingly based on which function you're working on. All right, so in the nutshell, that is what a logarithmic function looks like. Well, the base could be different. So the closer, this is the key. The smaller your base is, the further away you are from the x-axis. If your base is big, then the curve is closer to the what? To the x-axis. So we did something similar with exponential functions. Here in this case, if you have a base that is big, then you are closer to the x-axis. If the base is small, you are further away from the what? From the x-axis. Well, the cool thing about this function is that we can apply some of the things that we've been doing to all the other functions that we've learned. For every function that we have learned, we learn how to do some transformations. We learn how to find their domain and potentially their range if it's possible for us to. And do some more interesting things with them. So in the next video, we'll look at some transformations of logarithmic functions and keep on learning how to find their domain and range. Alrighty, thank you.